Okay, how are we doing so far? Um, anything, anything coming up that you want to clear up, or I can clear up, or everything? Were you able to get it working with that change, or? Okay, good. Yeah, there, if you have an earlier Java version, then I had basically kind of reinstalled everything on this computer, and I was using the latest one. So if you had an older versions, then mine wouldn't necessarily work. So if you've, everybody's been able to download mine, my stuff, and then as I add stuff to it, what you want to do is you want to keep pulling it. So, and I'll kind of show you what that's about. Anyway, so now we're going to start delving into the essence of what the conceptual part of this is about. So the two elements, the two threads of this course are, well, one is kind of learning Java. That's kind of the specific sort of things. But really the more conceptual piece of the course is this object-oriented stuff. And and if you go on message boards and Reddit or whatever, or there are people who are kind of who get all kind of get their undies in a real bunch about oh, object oriented is great. No, object oriented sucks. No, oh, we should do it this way. No, we do it. The thing is that this object oriented idea, it was a radical new approach that was taken a long time ago, back in the 60s actually, is when the ideas were starting to come out. And it's a way of designing large-scale programs that especially involve modeling situations where you have different entities that are interacting with each other. This is particularly useful if you're for things like combat simulations or agent-based models, where you can at least conceptually think of them as these entities, and that's what this idea of classes is all about. And so today there's this thing called UML. It stands for Unified Modeling Language. UML is actually we could spend the whole course just on all the different pieces of that. We're just going to look at something called a UML class diagram, and actually the UML in all of its glory is actually much more complicated than what we're just going to have a simplified version of that, which is useful. There are other pieces of UML that are kind of useful. There's a lot of it that's just, in my opinion, a bit of just unnecessary overhead. But the UML class diagrams are really useful, and as we'll see, hopefully, it's a way of kind of really getting you jump started on creating your class. In other words, instead of sitting down and starting to bang out code, you basically get a pencil and paper or a piece of software that works on these types of things, and you plan your class out so that before you even type a line of code, you already have an idea of what you're doing, instead of just staring at some blank stuff and flailing around. Encapsulation, which is one of the key concepts and one of the ideas behind why object-oriented programming or object-oriented design tends to work better for large programs. And then just some specific stuff about constructors. So what the key elements of a Java class are, and I want to just probably should have made this a little more clear. There are actually kind of two flavors of Java classes, at least. So far, everything that we've been doing and you've been doing code-wise has been a class, but for the most part. So all those ones with the main method, I mean, that's a class. In Java, everything is in a class. That's one of the things that Java did that it was kind of a good idea in a way, but the classes that have the main methods that we've been using, those are really kind of, I'm not quite sure exactly what to call it. You can call them main classes or whatever. In a sense, they're almost throwaway. They're ones that they're kind of a one and done. A Java component class, and I'm going to use the word component when we describe them, is going to be reusable. It's going to be something where where you have it in a library and you're using it. So examples that we've seen of this have been things like the Java string class. I mean, that's a component class because we've been instantiating it all over the place. The scanner class is another example of that. It's one where you instantiate it and you use it in many, many other different contexts. So that's what I call a component, because that's something where it's not just kind of a one and done. It's something where you can use it in a number of different settings. So encapsulation, that's that's one of the most important ideas. And then in terms of something concrete, if you see this UML diagram, can you create a skeleton of a Java class just by translating that? And what's nice about that is that you can get a lot of your class done without doing too much thinking. So see, ideally, when you're programming, you want to do as little thinking as possible. No pushback on that. What do I mean by that? What I mean is that what you're doing is just kind of doing something just very pro forma. You're not sort of sitting there trying to come up with a fancy algorithm or something. There's a time when you have to do that, where you have to say, okay, no, I have this thing I need to get done. How do I get that done? Okay, that's thinking. But it's like, how do I, here's a UML diagram. How can I create a skeleton of a class to that? No thinking. You just take it and you bang it in. You don't even have to use your higher cognitive functions. So the more thinking you do, kind of the worse things are. Just anyway. Okay, so this component idea. So a component class, it consists of two things. It consists of, and then there are different terminology for this. I'm not overly fond of the terminology that the book uses, but that it's just terminology. So state, the book I think calls it attributes. I prefer to use the term instance variable, because an instance variable is kind of what it is. So a Java component because of state and behavior. That's at the highest abstract level. That's a way to think of it. And what's powerful about that is that is a programming abstract modeling of, we can think of it as actual physical things. So for example, like the lights here, or I'm not sure which one's so you have a light, and we can model this the state of the light is going to be either on or off. Okay, so right now they're off, but if I go over here and I flick this, now the state of each of these lights is on. Now, what have I done? Have I gotten on a ladder, taken the light apart, and kind of done something on the interior of it? No, I've flicked this. So this is the behavior. I've done a behavior to influence the state of the light. And that's how ideally these objects work. In other words, I have a state which we're going to model in different situations as in various degrees of abstraction, and behavior, which is often how we might modify that state or get information about that state. So, we can use it to model the structure of real world objects, either, or even objects that don't exist in the real world. Okay, so the other term that I like to use is interface. So the interface is like the behavior that anybody can do. Like any one of us can come and flick this light on or off. So this is a public interface. It's open to anybody who sort of sees here can kind of flick it. It's not like, okay, no, you can do it, you can do, no, not you. Anybody, public interface. So the public-facing methods are the interface of the class. And that's how other objects will interact with it. So in this situation, I would be one object. And I would have a way of accessing this method. And so I would send a message, like one of my methods would send a message to this method to say, okay, go on. And then another message of mine might send a message to say, now go off. Say, so one object, another object. The other thing is this is, it's very abstract. So what I have the physical dimensions of this. I have the color. I have the wiring that's kind of hooked up to this. I have there's the size of these. There's how many lumens there are. There's the dimensions of the bulb itself. There's the mechanism on the interior of how it actually makes the light. None of that would be in an abstract model if I'm just saying on or off. That's all, in a certain context, that's all I care about. All I care is it on or is it off? And how can I turn it on, can I turn it off? That's an abstract level. If it were a different context, I might need more information about it. So there's no one level of abstraction when we're actually creating a model of something that is, quote, the right one. So this is this UML thing that we're talking about, and it basically describes the, oops, no, what I want is a pen. There we go. Okay, so it describes the class structure, and it has three pieces. One has the name, so the class name is right here. You have the instance variables and their type. And this is classic. UML was invented back when C++ was the dominant language, and so it's kind of C++-y. But and so what they do is they have a bunch of other little things that they have, and they typically go name and then type. But it's in a Java context, it's preferable to just you would do it the way the Java would do it. So Java goes type, name. Okay, so these are the instance variables, and then these are all the different methods, including these are the constructors. Okay, so constructors are like a method. Okay. So what do we have here? So we have the name of this class is going to be called a course, and this is going to be a little. The book kind of talks about this. Okay, so it has three instance variables. It has one called name, which is going to be of type string, an int called number of days, and a double called price per person. So those are the three instance variables, or state, or attributes, as the book calls them. Okay, it will in this case, it's going to have two constructors, and this design is a little bit different than the book. The book has a zero argument constructor. I'll explain why this is why I disagree with that. So that's kind of thing. How should I say? It's like if you get 5 programmers in a room, you're going to have 5 different opinions about things. So here there are two programmers in the room. There's me and there's the author of the book, and since I have a louder voice at this point, than the author, because the author is in New Zealand and he can't talk that loud, so you have to listen to me. So when there's a disparity between what I say and what the book says, go with what I say. But that's it. Usually it's a good idea to kind of go with the instructor, but you know, at least until the course is over, and then you can kind of, then I can't do anything to you. Okay, so there are two constructors. We're going to delve a little bit more into this sort of overloading concept. We've touched on it before. We're going to circle back to it, but here we encounter two constructors. And so, and then here are the other methods. So it has a method, a getter called getName. They're actually all getters and setters. And this is a little bit different. Oh, and then here's one that's been added. And what, notice that there's a toString method that returns a string. And that's in, notice that that's in italics. And that indicates an overloaded method. Okay, what is that? Again, that's something we're going to go into a little more detail, but just briefly, an overloaded method is one where the method already exists because of what's going on in the superclass. We'll get into all of that, and we're going to do something different with it. That's one of the things that when we get into something called inheritance and that, again, object-oriented stuff was about that. So the method descriptions include the name, the signature, and the signature is the argument. So here, the signature is 0 argument. 0 argument, here the signature is int. Here the signature is string, and here the signature is string, int, and double. Okay, so signature is what the types of arguments are to a method or a constructor. And then the return type. So for a method, we need to list the return type. And for a constructor, we don't need to list the return type because the return on a constructor is always a new instance of that class. So there's always a return. It's just that with a constructor, there's only one thing, you know, that, I mean, it's, how should I say, it's like if there's nothing to prevent, if I have a method called getName, there is nothing to prevent me from returning, say, an int. I mean, it would be kind of silly, but there's no law against that. I mean, so the return type on a method can be anything, and it can also be void. Like there always has to be a declared return type, and if the method doesn't return anything, you have to say void. So a void return type means this method is not going to return anything. Okay, so that's the UML diagram, and we're going to come back to that and actually build that class. But this encapsulation idea is one that it's worth it to kind of harangue on this. So you'll have to do. Okay, so there you can think of it as two views of an object. So there's the internal view, and internally, all of the methods have access to all of the data, all of the instance variables. Everything on the inside of a class has access to everything else on the inside of a class. So every method has access to every other method. Every method has access to every other variable. And in particular, now the constructor has access to other methods, but and in principle, you also have access to the constructor. I mean, it's a rare thing, but a method could instantiate another version of itself. And sometimes we actually want to do that. Sometimes there is a method that says, make a new object that's a copy of this one and give it to me. Java actually tried to do that. They kind of screwed it up, but there's actually a method that called clone, and unfortunately they kind of screwed it up, so it's not so useful. But there is, well, it's useful in exactly one context that we'll see later in the course. Okay, so that's inside. Everything can be seen by everything else. And the way to think of that, the way to remember that is this idea of scope that I talked about. Okay, what is scope in Java here? Is everything inside the curly braces. So in a class, what is it that composes the class? The curly braces. You would say public class, name, curly brace, close curly brace. Everything inside of that has all the scope within that. So if you just think scope, then you don't have to remember too much else. Okay, so that's the internals. External are you can think of the services that the object provides and how it interacts with the rest of the system. So in this light example, the service that it provided was a switch that goes either on or off. So the object, we can think of it as kind of encapsulating. In other words, the state of the light, it's like the state of the light is encapsulated because I can't reach in and directly change it. I have to change it only through the interface. So in designing our system, in designing our program, we can have like one object, and we can think of it as a client, and using another object for the service it provides. So if I'm the client and the light is providing a service that I can interact with using that interface of the switch. Now, this is what I like to call the principle of ignorance and apathy, and I think I've sort of said this before, but I didn't get the chuckle that I was hoping for, but that's okay. Ignorance and apathy, don't know, don't care. So how, when I flick that switch, how does that light go on? And I don't know and I don't care. If I want that light to go on and it goes on when I flick the switch, how it does that, that's not my business. So all I care about is I interact with it that way. How it does it, that's what it does. That idea is a really important one, so that when I invoke a method on an object from the outside, how does it doing that? Don't know, don't care. All I care about is it getting the result that I want. So any changes to an object state, that is its instance variables, should be made by that object's method. And so we should make it difficult, if not impossible, for a client to access those variables directly. In other words, it is difficult for me to access the internals of this, like how it's doing this. I mean, behind here, there are presumably wires that kind of go through some mechanism and eventually wind up there. And now it's not impossible, but I mean, I could start taking this apart, start knocking this wall down, start pulling on wires. Okay, so it's not impossible. But you want to make that difficult because you don't want people doing that. And likewise with an object, you don't want people getting their hands on their private parts, their instance variables. And so, so we want to interact with it like as if it were a black box. So I like this diagram. So the idea is that the client, another object, will interact with it only through the methods, and internally the methods are going to play with the data. Okay, so I want to demonstrate this with this. Let's erase all this. All right. So so how do we do this in NetBeans? So I want to have both of these.